Thanks, Jenna, for the introduction. My name is Yuqing Yang. I'm from the Ohio State University. So this work is a joint work between Ohio State University and the Drexel University. So in short, we have got the first Miniapp Malware dataset in this field, and we performed the taxonomy of those payloads that they're conducting, and we did a characterization of the Miniapp Malware throughout their life cycles. So we start from, it's about Miniapp and malware. So I'm going to briefly introduce what is a Miniapp. So the previous talk has done a pretty good introduction, so I'll make it brief. Imagine that you have a phone, that you have thousands and hundreds of the applications, but sometimes you just run short in the memories and you want to just uninstall some of the application, but it's hard to find, right? For example, you have the hotels, you have to do the ride hailing, you have to dine, and you have to deal with the bankings. So it's so hard for you to choose. But imagine if somehow there was a huge application that can connect all of these functionalities within this app. So this app essentially becomes operating system. It allows third-party developers to embed some lightweight packages. It's very lightweight, it's quick, and you can solve everything inside one single application. So we call it a mini-app ecosystem, which is an app-in-app system. The application in the center becomes sort of an operating system. So basically, this is a cross-platform solution. You can use it in iOS or the Android. You don't have to worry too much about it. And it has an optimized versatility and functionality because you can choose your only favorite services. So it's a product meets your own needs and it merges the convenience between the web pages, and you can scan the QR code. It's easy to share among the users. But what about the malware? So you probably have seen this before if you watch the YouTube videos, and this is sometimes a spam game, and you play it, you never get the money back. And we Chinese students may have also encountered this one. You just purchase and buy the gadgets, and you just slice to the enemies and just 9,900, HP damage. But these sort of things are the things we're worried about because it's sort of a spamming game. It causes some kind of financial losses or even the privacy losses. So we define them as the application that violates the regulation and the legislations. This is more severe, like for the laws, and also may inflict those financial or privacy losses to the users. So why we care about this problem? Because the super app platforms are very huge. It involves billions of user data resources, and it involves millions of revenues from those mini apps. If there was impersonation, it can cause very high damage. And what makes it even worse is that there was a rapid propagation because it's shared between you and your friends. So it's among the social network. Users are tend to believe what their friends sent to them instead of from a stranger. So we care about this distribution scheme. Finding the malware is still very challenging. You see all of the platforms have the saying that what can be done, what cannot be done, but the definitions are vague, and there are so many different types of new sort of malicious behavior. So, for example, like the mechanism abuse, like you abuse the sharing and the data, and like the fraud schemes and pyramid selling, intellectual property, stealing, anything about it. So we cannot just do a one-on-one categorization. We want to have a seed data set to deal with the malware in general. So we're going to introduce you to the evasive behavior, which is sort of a very traditional and common issue in the web society. Like, for example, we have vetting. Yes, super apps have the vetting. And if you want to keep the bad guys away, the best way to do is to examine all of the packages and kick out those bad guys, right? So vetting is so important because if you do it right, the only single entry solves all the question. But we saw many malware that escaped it. Why? Because when they're being vetted, it appears to be benign. But immediately after being vetted, it goes malicious. So from the platform's view, what happened when we examine that it's so safe, but after that, it just does the bad stuff? One of these ways to do is called the content vetting evasion, which means that you see there is an if, and there is a state that control what is going to be displayed. If it is 0, it shows some images, which is just an introduction. It can be iffy, but there is no interaction between the users. It's like this, yes. But if the state equals to 1, it becomes a web view that provides the actual spam gaming. So how it does is that this state variable is fetched from its backend, is controlled by the developers, not visible to the platform bettors. When they're being vetted, it's set to 0. And after it's being vetted, of course, developers know the mini apps are successfully vetted. They just change that variable to 1. and it can provide those things. So the vetting is completely bypassed. The second thing about that is the code vetting. So the cloud-delivered stuffs can be a variable, but can also become a code. And this piece of code, because JavaScript, it's a dynamic language, you can implement your own interpreters. And this is like you evaluate the value of the node, presumably for AST node tree. And there are also cases that tampering with the templates that display different things dynamically. So these sort of things are implementing an API to evaluate those node value that resembles like the hot update code, like eval. There are some oracles, because platforms knows it, starting from 2022, they ban all of these accesses. When they detect this kind of library, they just stop it from being vetted. But you can always get your own, embed that into your own code. But this provides a very important insight for us, because hot update is a very complex thing. Developers tend to re-implement things, like use their habits, like the different API invocation routines. So the function signatures are going to be kept in this case. So we're going to detect this thing. The analysis protocol is the insight. Both of these evasion techniques leave the traces in code, as you see. And we do two different checks. The first is the evasive signature, which means that for the code-based evasion, we check if there are JavaScript function signatures of those evasive or hot update libraries. For the content-based evasion, we check the WXML, which is similar to HTML. There are if flags, control different things that render some sort of web views. But we need something else, the platform removal check, the check from the platform. If this Miniapp is delisted, it is very likely that they are doing bad things, and the platform acknowledges of the malicious behavior. So this is important to prevent false positives. We did 4 years of the analysis, starting from 2020. The first collection yielded 4.6 million Miniapp packages, and we did a second round. The second round revealed 360,000 to be removed. Among these, we detect the signatures, as we said. Finally, it boils down to 19,000 identified malware as them. So, based on this, we did a very large lifecycle dissecting, including the propagation, activation, and the payload. Propagation involves that you can be discovered in the Miniapp store, but most importantly, you can share the Miniapps to the users, and either you can just be redirected to the new malware. For the activation, it can be on startup immediately when you open this Miniapp, or just after user interacts with it, like sharing the Miniapp. But we are going to deal a little bit more into the payload, which includes sensitive info collection, malicious service propagation, and those monetized traffic hijacking. So the first part is about the data collection, which is the first three categories of them. Like half of them are falling into this category. It can collect those information upon startup. If you have granted the location access to this Miniapp before, every time you open it up again, it will not ask you for the permission again. So your location status is automatically fetched. It can also fingerprint this device info, such as the brand, the model of yourself. These are not protected by those permissions from the super app. They can access it, perform the fingerprinting, and then try to pinpoint you, what kind of user you are. This kind of a privacy issue. And these privacy data can be shared among Miniapps without your own permission. So it can be acquired, or it can be stored, or it can be sent across the Miniapp, creating a collusion. This includes user interaction, Bluetooth access, like the microphone access, or the phone numbers, which is commonly used in the Miniapps as an account identifier. The second part of this is the monetizing malware, which means they are trying to earn money directly from the platform instead of the user, which is the rogue malware, incentivized sharing, and advertisement overload. To understand this, let's talk about how they are going to make money. So there is a cycle. First of all, you have the resources provided by the platform, which is basically the user data. You use the user data to provide services, and you can earn money by embedding the advertisement, and the money you earn is based on how many clicks towards your Miniapps. And then you distribute these Miniapps to more users, create more popularity, and you earn more money. But if you cheat in this system, you said, okay, you can share this mini app to the other users in order to use our service. Or I can give you part of the share if you share that mini app to the other users, usually just a few cents, but users would be willing to do. Who doesn't like a free lunch, right? So this creates a cheating of the traffic. You can see there are all sorts of different type of monetizing malware. This one is like you watch more videos, you get money, and you share to more users, you get more. And the second one is you complete very simple tasks like calculating 1 + 5, which doesn't make sense, but you can earn money. And also you can play with those red pocket, which is just a sort of lottery. You earn some share of the money randomly, and you share. But all of these, the bar is very high. You have to take a lot of time to withdraw those money. So we have sampled 500 miniapps for validation, 34 content vetting, and 400 code vetting. 13 false positives, 1 because of the semantic issues of the evasive API, and 3 because they're just video-based mini apps. So it's legit to have the if-controlled web views. Okay, let's do a recap. So we have a main contribution. We identify the Miniapp malware dataset, release them. Maliciousness can leave the traces, which is our insights. And we have the enhanced devastation because there are wider privacy impact and faster propagation through the social network, and the domain-specific uniqueness because the platforms can be the victims. We're releasing this dataset, and we have 4.6 million mini-apps. If any of you are interested, send me an email. We can craft what kind of things you need if we verify your identity. And we hope to involve more of us to get into this community, to try them out and have fun. If you do the program analysis or JavaScript analysis, it will be great for you to start from. We have accessed 9 or more institutions access this data set, and we hope that you can join our this new direction. This is for the talk, and thank you so much. Happy to take any questions.
Thank you. If you have questions, please walk to the mic.
The crucial issue about the malware is that many of the content are dynamically loaded from the server side. Is there a better way to detect or mitigate such issues?
Yes. Unfortunately, the detection, especially dynamic detection, is falling a little bit short than the platform themselves because they can have the large database. Some of them said that they can monitor the user behavior. If a user stays in an empty web view for too long, it can indicate there's something developers trying to hide from them. But from a static point of view, it's very hard to verify them because the dynamic loaded resources can be camouflaged, especially when certain criteria are not made. We're trying to do more in the dynamic analysis. We hope that in the future we can make more progresses in it.
Thank you.
Thank you.
For the threat validity, you only show the false positives of your checking rules. Have you examined its false negatives? Because I think you are only focusing on hot updates. If there are some other Miniapp malwares, will you neglect them?
Yes, of course there can be more Miniapp malwares, but the things that we do here is that under this definition, the evasive signature is much more concrete, so we're able to verify them. But if you say that in a broader sense, there could be some other cases we haven't been covering, so that is what we are trying to find more of the cases. By starting from this data set, we can find more insights. And based on this assumption, so we think that the false positive is much more important, and we hope that we can find more to reduce the potential false negatives.
One more question.
Yeah.
So the false negative can introduce some bias of this data set. If you start from this, well, the resulted research can based on the biased one because they are all from the.
So, for example, what kind of bias do you anticipate by the false negative?
They are all from the hot updates apps. If there are some malware that are not hot updates, they just original malware.
I think if so, that should be a false positive, right? Because we identified them, or just because you said that they're not hot update.
Yeah, they are not hot update.
Yeah, if so, I think they fall under the false positive category, right?
False negative, I think, because your check rules only check hot update ones. So these are not hot updated one. You just
Oh, you mean?
you just
I see.
they're bypass your checking.
Yeah, I think that is the case we can start from. And I believe that there are some malicious activities that carried out, and you can find some of the hints based on this data set. Because a Miniapp malware usually have multiple different maliciousness due to our examination. For some certain malicious activities, they may try to evade. For some others, they may have other capability or behaviors. So that's why we're trying to take a much closer look and detailed look on what exactly they're doing for each of these cases we have.
Thank you.
Yeah, I mean, this is like a starting point that we start for the first data set. So that in the future, we expect to expand the coverage and the definition of this.
I see.
Thank you.
Thank you.
One more question?
Yeah, go ahead.
Yeah.
So this is David from University of Melbourne and also Zero.61. So I would like to ask one question because my work is very similar like you. So, but that is on the deceived patterns, or people will call it dark pattern.
Mm-hmm.
And I would like to ask, is there any brief idea of how you are going to migrate this kind of risk?
To which part of this?
Let's say if you have a brief idea to, let's say, avoid the user to, let's say, jump into the trick.
Yes. Currently, we are collaborating with the platforms to share our methodology, and definitely they have some more accurate one, but they have to take time. And ours seems to be a little bit like preventional. Hopefully, there will be some changes in the event, and sometimes the mini apps are actively being taken down, and for sometimes there will be some hints on this mini app may contain some suspicious, or you have to be more careful about the payment and something like that. Actually, they're doing some work. So I think the only way to do this is to collaborate with the exact platforms, collaborate with the industry to deploy our things and to see them feedback.
Okay, one more question. Like, from your understanding, who should take the responsibility to undertake the user's loss? Like the developer or the provider, the APP provider?
You know what? I really like your question. So this is like the platform usually don't want to, concede that is there a problem, but we usually butcher them pretty hard. Yeah. From my perspective of view, is that the platform, as the provider of the infrastructure, they have to get some mechanisms and to inform the developers to use them. If so, they can be free of the liability of these things. Otherwise, I think it's the platform's capability because it's them who provide these things, and developers and users trust them. But they felt this trust of chain, right?
Yeah.
I think they have to do at least some part of it.
Okay, thank you so much.
Thank you.
Okay, let's thank our speaker again.
Thank you so much.